Okay, so let's try this again. Thanks to Liza pointing me out that for whatever reason, the audio did not record. So we'll put this out a second time. Hopefully you all can hear me now. Apologize for that. I have absolutely no idea what happened. Okay, so let's start at the beginning. Just so that everybody's aware of the parameters. So you're going to have two different sets of bulbs. The high resistance bulbs are 40. The low resistance bulbs are 10. And we're going to set the batteries at 20 volts. Okay? So if you go into the FET simulation, you can, if you tap on that battery, you can change your voltage to whatever you want it to be. Okay, in this case, we want that at 20. If you tap on the bulb, you can set those at 10 or 40. Okay, slide that, boom, easy enough. Okay, so what we're going to look at here is the whole purpose of this lab is to force you to think through how current and voltage and resistance affects the brightness of bulbs. So they've actually studied this, and the reason that we're going to use this simulation, beyond the fact that I can't actually get you into the labs, is because of the fact that if you actually tried to do this with labs, and what they found is that in a real lab situation with actual bulbs, there's enough discrepancies in the resistance of the bulbs that sometimes you get like an observation that you shouldn't have. And the problem is that if you have like a preconceived idea of what should happen, and then the lab works and you get that wrong result because of the distance, or because of the difference in the brightness of the bulbs, then that just reinforces it, and then no matter what happens, I cannot undo it. So this is the beauty of this simulation, is that the bulbs glow like they should, and that's the beauty of this. So now let me explain the spirit of this lab and how I wrote it. The idea being is that you're going to predict what's going to happen to the brightness of these bulbs. Now, let's make sure everybody's cool. So this is the positive terminal of the battery, the one with the bigger slash mark, and we're going to assume that the current is going in the conventional sense from the positive around to the negative. So this current's going to be flowing around like this. So what I want you to do is to actually predict what's going to happen to the bulb. So in other words, if you think, since the current is going this way, if you think this first bulb is going to be brighter than the second one, then you're going to write 1 and 2. If you think they're both going to have the same brightness, okay, then you would write 1 and 1. Now, here's what's important. You're only comparing the brightness of the bulbs within the circuit. You are not comparing them to the brightness of the bulbs over here. Okay, that isn't the point. When you're ranking them, you're only ranking them in the context of the circuit itself, not in terms of the other one beside it. So the idea being is that you're actually going to make this prediction. Now, if we were actually doing in the lab, I'd kind of have like maybe Liza and Bruce working together, and Liza would say, hey, I think this one's going to be brighter than this one. And then Bruce would say, well, I think that they're both going to be the same brightness. And then you'd actually build it, and then you'd actually say, oh, what actually happened? So this is why you have two sets of columns, where you set a prediction and then the actual. Now, y'all are doing this on your own. I can't verify that you actually predicted it, but that's, in the spirit of the lab, that's what I wanted to have happen, where you would actually make these predictions and then you would build the circuits to see what's going to be taking place. So that's why those are there. So please work with it in the spirit of the lab. So, like here, the current's coming out. Okay, it's going to go here, it's going to go here. Are these going to be the same brightness, or are these going to be different? Okay? If you think one's brighter, write a 1, and then the one that's going to be less dim is going to put a 2. Okay, in terms of the calculations, down here when you're calculating like the current in like this, these are the more complicated ones. Like if you go to cluster number 5, where you have current in low, current in LB, current in high. What I'm talking about on those, and I stress this, is that I don't want the current in the entire circuit. I want the current that's going to LA. I want the current that's going to LB. I want the current that's going to the high side. So even though I tell you that in the instructions, okay, read the instructions. So on cluster number 4, current on the low, current in the high. So on cluster number 4, I only want the current that's flowing into the high side, and I want the current that's flowing into, or the low side and then on the high side. I don't want the current up here. I want the current after it's been split. So this is a deal where you're going to have to go through and do those calculations. Now, I know you all have ammeters, and when you build this, you can actually test it. But remember, on the test, you're not going to have, theoretically, this program to build these circuits to test it. So you've got to be able to do these calculations of current and voltage and then use the program to verify it. That's how I want this whole deal to play out. Build them, okay? Build them, predict it, see what's going to happen. Now, when you get to this last question, okay, I do not want this actually handed in to me, okay? I've already sent you the answer key to this. Do not do this. Now, if you're taking the AP test, do this question, okay? Because this is the type of question that you're going to see. If you're not taking the AP test and you really want to make sure that you understand it, work the question, okay? But do not hand this part in. Stop right here. Stop right there. Do not pass go. Do not collect $200. I only want this up through this last part here, okay? Okay, now, when you're sending in these files, and some of you are getting the hang of this, but I cannot emphasize this enough. When you all are sending in files, so let's say Tate just got done sending in a file and I send it back to him. So when you take this with that scanner app, so you would name this like Tate Bulb Lab, okay? That's how I want this thing done. Do not just let it randomly generate that code. Go through, backspace out of that, get rid of everything. This is the only thing that I want when you name that document, okay? I cannot emphasize this enough. I want that named like that. Okay, so this is kind of a cool lab. It's going to make you think, okay? But again, I beg of you, pay attention to the spirit of the lab. You're supposed to make predictions and then see what actually is going to happen. Now, listen to me. I do not want this lab until Friday morning, okay? I've got enough stuff to grade, okay? Do not, listen to me, Ryan Easton, do not send me this lab before Friday morning, okay? Do not send this before Friday morning. I need to grade assignment 23-1. Some of you have that circuits lab done. If you want to hand in the circuits lab, that's fine. I do not want this bulb lab before Friday morning, okay? Oh, please. Okay, anyway, that's the story, kids. I apologize for that first one. I have no idea what happened. Shout out to Liza for pointing out that there was no audio. Anyway, so again, I cannot stress this. You're only comparing the brightness within the circuit, not to other ones in that same set. Make sure that you can do these calculations. This would be handy if you could print this out, just because of how you're going to be writing these predictions on here. If you can't, and you just want to kind of draw them or write out, hey, here's what I predicted, here's what actually happened, that's cool. But I'd prefer that you actually have that printed out. So anyway, that's the story, kids. I'll get this uploaded again. See ya.